In today's session, we are going to discuss about one of the major event taking place in the process of respiration, that is the transport of respiratory gases like oxygen and carbon dioxide. We have blood, the major medium through which the transport of oxygen as well as the transport of carbon dioxide takes place. Let us go for the transport of oxygen first. We are all knowing that in our blood, RBC holds a major respiratory pigment we call as hemoglobin. Hemoglobin has got a high affinity with the gas oxygen. Now, when we say the transport of oxygen, there are two major methods by which oxygen gets transported through blood. Around 97% of oxygen is transported through this respiratory pigment hemoglobin in the form of oxyhemoglobin, and the rest very minimal amount, that is only 3%, which is transported in the form of dissolved oxygen in blood plasma. Let us go for the first transport technique in the form of oxyhemoglobin. This oxygen molecule will combine with hemoglobin in the presence of the oxygen, the large amount of oxygen, and form a complex we call as oxyhemoglobin. And when we say hemoglobin, it is a protein. So this hemoglobin molecule has got the capacity to hold 4 oxygen molecules. So every hemoglobin molecule can be saturated, can be holding by 4 oxygen molecules. So this oxygen molecule can combine with hemoglobin when the PO2, partial pressure of oxygen, is high and the partial pressure of carbon dioxide is low. Now there is a question that what is ultimately this partial pressure? When we go for the diffusion as well as the transport of the respiratory gas, the principle of partial pressure acts a major role. Partial pressure represents the amount or the pressure at which a particular gas exert on a mixture of gases. So here the particular gas is oxygen. So the pressure at which the oxygen exert on the pressure of the total atmospheric pressure or total gaseous pressures. So here high PO2 is found in alveoli because alveolar space is filled with oxygen containing air from the atmosphere by inspiration, and low PCO2 is found in the alveoli. And when this is the condition, when high PO2 and low PCO2, there is a complex formation, that is oxyhemoglobin. This oxyhemoglobin will be carried throughout the blood and reaches to our tissue for cellular respiration. And after this, you can see that this will be giving the oxygen, that means this complex will give the oxygen to the tissues and the HB will come back. This will be almost like ferry boat carrying the passengers from one side of the river to the other side. When the passenger wants to go to the other side, naturally what will happen? The ferry boat will leave the passenger at the other bank and the ferry comes back for taking the next passenger from the other side of the river. Now, if the condition is high PCO2 and low PO2, the reverse reaction will take place. That means this oxyhemoglobin will be dissociating into hemoglobin and oxygen. That is normally happens at the tissues. So you can say that at the tissues, reverse order will happen. In the alveoli, the normal hemoglobin, oxyhemoglobin will takes place. Now, you can see a graph depicted here. This graph is representing the oxygen carrying capacity of hemoglobin. You call it as oxygen hemoglobin dissociation curve. This is given in your NCERT textbook also. In the normal condition, this oxyhemoglobin curve is a sigmoid curve. That means S-shaped curve. And in this curve, you can see that it is depicted on the x-axis, the partial pressure of oxygen, and the y-axis is depicted with the percentage of saturation of Hb. What is the meaning of percentage of saturation? When all the hemoglobin molecules are loaded with or saturated with these oxygen molecules. So this is what we call how much amount of oxygen is loaded with or saturated with our Hb. And any change happens, for example, if this pH is high or if high alkalinity comes, this sigmoid curve will be shifting to the left side. If less pH come, acidity can be causing less pH. This sigmoid curve will be shifted to right side. So by seeing this kind of curve, you can understand that what is the present condition. Now you may get a question, how come this acidity is found in our blood? We can see that carbon dioxide gas will combine with water present in the blood plasma. Our blood plasma contains 90% of water. So whenever carbon dioxide amount is high, there is a chance of combining with water present in the blood plasma and forms the corresponding acid, that is carbonic acid. Due to this carbonic acid, the pH turns to less and our normal sigmoid curve will shift to right side. If pH is more, that can cause an alkalinity. As a result, the normal sigmoid curve is shifting to the left side. This same condition can happen when the temperature variation comes. In low temperature, it can shift to the right side. In high temperature, it can shift to the left side. So this is all about the transport of oxygen through blood. This can be 97% in the form of the complex formation, the oxyhemoglobin. Now let us see that how carbon dioxide is getting transported. 7% of carbon dioxide is in the same way dissolving in water present in blood plasma, because water has got a high dissolving capacity of carbon dioxide, and the majority 70% is by the formation of bicarbonate ions, and rest 23 is by carbaminohemoglobin. I will just go with carbaminohemoglobin also, because hemoglobin once reaches the tissue, carbon dioxide content is more. So that hemoglobin will be left alone. Once that oxygen is left in the tissues, the hemoglobin will be free. That hemoglobin will combine with carbon dioxide and form a complex. You call it as carbaminohemoglobin, and this carbaminohemoglobin will come back to our alveoli for releasing carbon dioxide. Now let us see the major chunk of this carbon dioxide, how 70% of carbon dioxide forms in the form of bicarbonate ion. That is a very great incident happening inside the RBC. Let us see what exactly happens in the RBC. All can see this as the RBC, red blood cell. And outside the RBC there is a liquid plasma present. Now suppose carbon dioxide molecule diffuses inside the RBC. Inside the RBC there is a very popular enzyme present. The name of the enzyme is carbonic anhydrase, which has got a great capacity to catalyze the reaction of carbon dioxide combining with water and forming the corresponding carbonic acid formation. And due to the presence and the high activity of this carbonic anhydrase, the same carbonic acid formation takes place inside the RBC cytoplasm. And the same enzyme will catalyze for the ionization of this carbonic acid. You can see that immediately the carbonic acid can dissociate into a negatively charged bicarbonate ion. This is the negatively charged bicarbonate ion and the positively charged hydrogen ion. So we are seeing that carbonic acid which is formed by the activity of carbonic anhydrase enzyme is getting ionized in the form of two ions, negatively charged bicarbonate ion and the positively charged hydrogen ions. This negatively charged bicarbonate ions will be carried along with the RBC and it will reach to the alveoli for the expiration. So this is the method by which 70% of carbon dioxide is transported through the RBC in the form of bicarbonate ions. Once again we can get a recap. Transport of oxygen, major event by oxyhemoglobin complex formation. And the transport of carbon dioxide is mainly by the major event by the formation of bicarbonate ion. And the rest are all by the blood plasma, dissolving capacity in blood plasma. Bicarbonate ion we have seen formed by the help of carbonic anhydrase enzyme by the ionization of carbonic acid. We have seen that carbonic acid formation takes place inside the plasma by the help of water present inside the RBC. I hope that both the processes of oxygen transport as well as the carbon dioxide transport through blood is clear now. Thank you.